Self-assembly refers to aggregation of particles into an organized structure without external assistance. This video used soda straw to demonstrate a microscopic self-assembly at gas-liquid interface. These soda straws are structural particles. Capillarity force is the binding force. The water-filled container is the environment. The applied vibrant is the drying force. The attractive drying force behind this self-assembly process are based on the interaction between the unit and the meniscus, also referred to as capillary interactions. Place a single straw in a bowl of water, and its weight will cause the water beneath it to dip slightly, forming a dent in the one smooth surface of water. A second straw placed into the bowl will form its own dent on the surface of water, and if the two straws drift close enough to each other, they will appear to fall into one another, as if pulled together by the attractive force. Let's see what happens when we add more straws. We define two directions and count the number of straws that are consecutive arranged in both directions. Obviously, the number of straws or the increase in density allowed them to assemble a huge structure. A higher concentration will lead a higher likelihood of particles interacting with each other. Relative literature suggests that this actually changed the environment. This experience reveals a dependence of the final configuration on in-situ particle density. When the soda straws are cut at non-90-degree angles, there are fewer end-to-end interactions between them. We can see that straws with some 45-degree angle cut ends are assembled together. It is a simple demonstration for self-assembly using shape matching.